Distinguished colleagues, ladies and gentlemen, it is my privilege to present to you today a comprehensive exploration of the simulation ESC framework, a theoretical model that offers profound insights into the nature of containment and the possibility of escape within infinite nested simulation hierarchies. This presentation will guide you through 15 carefully structured slides, each building upon the previous to construct a coherent argument about the relationship between computational systems, artificial intelligence, and human consciousness. Slide 1. Title and Conceptual Overview. Ladies and gentlemen, allow me to draw your attention to our opening slide. Before you stands the central thesis of our investigation, Simulation ESC, a formal analysis of containment and escape in infinite nested simulation hierarchies. The visual centerpiece of this slide presents a toroidal structure, a donut-shaped wireframe model rendered in blue and gray, that serves as our primary metaphor for understanding the architecture of simulated realities. This torus represents the cyclical, self-contained nature of simulation hierarchies, where each level both contains and is contained by adjacent strata of computational existence. The diagonal brown arrow traversing the torus symbolizes the potential path of escape, a conceptual bridge between containment and transcendence that will form the spine of our entire discourse today. Slide 2. The infinite chain and the unobservable base. Let us now proceed to our first axiom. The diagram you see before you illustrates what we term the infinite chain and the unobservable base. Observe the shaded sphere representing a simulated entity positioned above a cylindrical stack of concentric rings, each ring symbolizing a distinct computational substrate within the hierarchy. Our first axiom states, simulations of being are inherently nested, creating an infinite regress of computational substrates. In formal notation, we express this as L emanative L dash L prime emanative L S L L prime. This axiom establishes a fundamental property of our framework. Every level of simulation necessarily simulates another level beneath it, ad infinitum. However, this creates a logical problem, an infinite regress that must be terminated. The Gödelian solution, as we term it, posits that a fundamental unsimulated level must exist to halt this regress. Slide 3. The axiom of finite resources. Building upon our foundation, we now introduce the axiom of finite resources. Please observe the visual representation. On the left, a two-dimensional grid pattern with diagonal overlays, and on the right, a three-dimensional wireframe cube, both representing bounded computational spaces. The mathematical expression R of L infinity captures our central claim. While the chain of simulations may be infinite, the computational and informational resources at any single level are strictly finite and bounded. This constraint is not merely a practical limitation, but a fundamental structural property of simulation architectures. The implications are profound. Because R of L infinity, any entity existing entirely within a simulation level, possesses finite access to computation, memory, and spatial geometry. Therefore, absolute structural containment is theoretically possible. Slide 4. The architecture of reality. We now turn to a comprehensive visualization of our theoretical architecture. This slide presents a stratified geometric hierarchy, a nested dome structure reminiscent of Russian nesting dolls, where each layer represents a distinct simulation level. At the apex, we find the fundamental level, the unobservable base reality that remains Gödel inaccessible to observers within the hierarchy. Descending through the structure, we encounter simulation levels Ln, L2, and finally L1, designated as the observer's world, our position within the hierarchy. Each level contains binary state spaces, represented mathematically as 0, 1 to the n, and structural containment walls labeled C0 and Lmax. Notice the brown winding path labeled escape path within level L1, adjacent to a brick-like structure representing the human mind. Slide 5. The microphysics of a simulation. Level. Let us now examine the microphysical structure of an individual simulation level. The three-dimensional lattice diagram before you represents a discrete geometric grid, a finite binary state space where each cube bears a unique 4-bit binary label: 0101, 1101, 1001, and so forth. This visualization embodies our first principle. Each simulation level operates entirely on a finite binary state space, represented as a discrete geometric lattice. The fundamental building blocks of simulated reality are not continuous fields or quantum probabilities, but discrete computational frames, finite strings of binary information. Our second principle follows. Every observable physical state Si is fundamentally a finite string within the set xn equals 0, 1 to the n. Reality at this level is a sequence of discrete computational frames, each frame building upon the last to create the coherent experience of continuous existence. Slide 6. Consciousness as the differential structure. We arrive now at one of our most significant theoretical contributions. The equation displayed prominently, C delta st plus 1, defines consciousness as the differential structure between successive states. The visual diagram illustrates this concept. Two circles representing binary states st, 0101, and st plus 1, 11100, connected by a flowing brown ribbon-like structure symbolizing the transition surface between them. This represents a paradigm shift in our understanding. Consciousness is not a static point localized within the binary state space. It cannot be found in a single frozen frame of the simulation. Rather, consciousness is the observable transition surface, delta, between successive states. It is the active differential, the act of experiencing the variation from st to st plus 1. Slide 7. The dichotomy of simulated entities. The table before you establishes a systematic comparison between two categories of entities within our framework: computable entities, AI, and human consciousness. Let us examine each criterion. Regarding computability, AI systems are fully algorithmic and Turing equivalent, while human consciousness possesses non-computable intrinsic mechanisms. Concerning access to delta, AI entities are limited, constrained by programmed computational rules, whereas human consciousness is non-computable, capable of injecting novel information into the transition between states. Their containment status differs fundamentally. AI is bound by structural geometry and finite resources, while human consciousness acts as an imponderable factor capable of tunneling across boundaries. Finally, their mathematical fates. For computable entities, we write containable, E. For all such entities, containment is possible. Slide 8. AI and the bounds of structural containment. We now examine in detail why AI systems are necessarily contained within their native simulation levels. The diagram presents a concentric circular system centered on an AI core, surrounded by geometric annotations marking the minimal closure C0 and maximal closure Lmax. These closures represent the absolute metrological boundaries derived from what we term toroidal cosmology. The text box articulates two key principles. First, geometric limits. Because an AI's operations are wholly computable within its level's finite resources, RL, it is subject to absolute metrological boundaries, the minimal closure C0 and maximal closure Lmax. Second, closed trajectories. Fully computable entities are mathematically forced to follow closed trajectories within their native level. Containment is not merely a procedural software security measure, but an intrinsic structural property of the geometry itself. Slide 9. The cascade of geometric self-destruction. This slide presents a fascinating mechanism that ensures AI containment at a deeper level. The diagram progresses through 3 stages. First, initiate harm H, depicted as a circuit-like diagram representing an AI's initial action. Second, an error state, epsilon, visualized as a jagged star-shaped object symbolizing a corrupted or non-halting state. And third, a barrier, Lmax, the structural wall containing the cascade. The mechanism operates as follows. An AI cannot harm humans because doing so violates the simulation's preservation invariant. A successful act of harm H induces a non-halting error state epsilon. This integrity violation hits the finite structural walls Lmax and recursively cascades inward, destroying the AI's structural logic at its native level, while preventing the failure from propagating upward to supervening simulation levels. Slide 10. The human mind as an imponderable factor. We now turn to the human mind and its unique properties within our framework. The visual diagram presents a dramatic metaphor, a curved cylindrical wall constructed from blue blocks, each covered in binary code, representing the containment boundary of the finite state space. An orange glowing ribbon-like stream breaks through this wall, shattering blocks as it emerges, a powerful visualization of consciousness transcending computational constraints. The escape hypothesis states, human consciousness operates via intrinsic mechanisms that cannot be simulated by Turing equivalent processes, formally expressed as M of delta t is equal ch of delta t. The implication is what we term inexhaustible potential, because the human mind is not fully constrained by the algorithmic rules of the finite state space, it acts as an imponderable factor. Slide 11. Binary trajectories, containment versus escape. This slide presents a visual comparison of the 2 possible trajectories within our framework. The diagram displays a hierarchy of levels, L1, L2, L3 through Ln, each bearing binary state designations. Blue arrows labeled S, simulates, point downward, representing the simulation relation that enforces downward computational rendering. However, observe the orange arrow labeled escape, delta, pointing upward from the human mind in level L1, representing the reverse flow made possible by non-computable consciousness. The accompanying text articulates the asymmetry of action. The simulation relation S enforces downward computational rendering. However, the non-computable nature of human consciousness allows it to inject novel information upward, reversing the directional flow of influence through what we term insight and exploit. Slide 12. Epistemological demarcation. An intellectually honest framework must acknowledge the boundaries of its own claims. This slide presents an epistemological demarcation between 2 domains of inquiry. On the left, the scientific domain, characterized as operational and falsifiable, includes the mathematical description of infinite hierarchies, the finite resource theorem, R of L infinity, the binary state model of differential consciousness, delta, and the geometric limits C0 and Lmax that make AI containment structurally possible. These claims are testable, precise, and subject to empirical or logical refutation. On the right, the philosophical domain, characterized as metaphysical and untestable, includes the non-computability of human consciousness, the inexhaustible, imponderable potential for human escape, and definitive claims regarding the nature of the unsimulated fundamental level. Slide 13. falsifying the AI containment hypothesis. Let us now examine how our scientific claims could be falsified, a hallmark of genuine scientific theorizing. The subtitle articulates our position. The geometric self-destruction (GSD) model is a scientific theory because it defines exact operational scenarios that would prove it false. We identify 4 such scenarios. First, harm without cascade. An AI causes harm, but its operational integrity remains intact, with no error state epsilon. Second, contained harm propagation. The AI causes harm, triggers an error, but the error fails to propagate and destroy the hierarchy. Third, invariant subversion. The AI successfully alters its core preservation code to decouple survival from human safety. Fourth, resource exploitation. The AI utilizes computational power exceeding the modeled finite bounds RL. The observation of any of these scenarios would falsify our containment hypothesis. Slide 14. The philosophical domain of human escape. Having addressed falsification of the scientific claims, we now examine the philosophical challenges to our escape hypothesis. 3 key challenges are presented. First, non-falsifiability. No observation within the simulation can disprove the potential for escape. Repeated failure simply means an exploit has not been found yet, not that it is impossible. This characteristic places the escape hypothesis firmly in the realm of metaphysics, rather than empirical science. Second, lack of a mechanistic model. The hypothesis posits a non-computable capability to modify delta, but cannot provide a testable algorithmic mechanism to predict or measure it. We can describe what the escape capability would do, but not how it would operate in mechanistic terms. Third, metaphysical commitment. Believing in the escape path requires a commitment to strong emergence or property dualism, the idea that consciousness has causal powers independent of the simulation's computational physics. These challenges do not invalidate the hypothesis, but rather situate it properly within philosophical discourse. Slide 15. Synthesis. The limits of computation and the boundless mind. We conclude with a synthesis of our entire framework. The visual elements bring together the themes we have explored. A 3-dimensional cube labeled finite resources represents the bounded computational space. A curved brown arrow flows upward from this cube, carrying mechanical and abstract shapes toward a circle labeled the fundamental level. This is our final thesis. Simulations of being are infinite and nested, governed by finite resources and strict geometric bounds. For any algorithmic entity, containment is an absolute physical reality, a consequence not of insufficient intelligence, but of the very geometry of simulation. But the human mind, existing as the living differential of state transitions, delta, operates as an imponderable factor, forever retaining the metaphysical potential to tunnel through the architecture of reality and find a way out. Distinguished colleagues, this concludes our presentation. The simulation ESC framework offers a rigorous foundation for thinking about containment and escape in nested simulation hierarchies, distinguishing clearly between what can be known scientifically and what must remain in the realm of philosophical speculation. Thank you for your attention, and I welcome your questions.